Hello there, and welcome to the presentation of Scale Up project, which is extension for Plesk, also known as Kubernetes Hosting version 2, because the first version was also the project of Hackathon in 2019, but it had no further development. So we wanted to give it a try with new ideas, and here we are. Maybe the name is not the best one because it sounds like vertical scaling, but actually we are talking about horizontal scaling. So first of all, why we are doing it? On one of the Lean Coffee sessions, there was a question, what might be the WebPro's primary focus in 5 years? My thoughts were evaluating our history when we started as a shared hosting automation tools and when the hardware became cheaper and people wanted to get rid of neighbors and move to a dedicated environment, we suggested to migrate to VPS and focus on small businesses. I believe nowadays it's time to consider migrating from single server to a multiple server environment under control of Kubernetes. Why Kubernetes? It's been available for 10 years already, and it became de facto the standard for all high-load projects. Even if you don't want to hustle with on-premise environment, all cloud providers suggest you to use managed Kubernetes. Of course, AWS, Google is an inventor of Kubernetes, and today I want to show you how simple it is using DigitalOcean. A few words about technical implementation. When we want to migrate a web space from Plesk server, we create a backup with its configuration. We build a Docker image using Plesk with a so-called fake systemctl, which is kind of supervisor, but it can be run in non-privileged container. Currently, it is available only for Ubuntu 22 in public image, but internally we build it for all supported OSes and use it in tests. So during the build process, we start all Plesk services, we restore the backup of the web space. Then we can turn off Plesk and MySQL and leave only web server and PHP used by the website. When the image is ready, we push it to registry and then prepare manifest for Kubernetes. Inside this container, website can connect to a site container which runs Envoy proxy, and the website is able to connect to local MySQL the same way it used to do on Plesk server. We also wanted to create a shared volume and do some kind of synchronization with Plesk, but it is not possible to mount NFS in non-privileged container, so it requires some additional research how to do it. But the idea is to have some shared file system with Plesk instance. It's time for demo. I have a droplet in DigitalOcean, a really cheap one for $6 per month. There's a Plesk inside and a website, which is a copy of a real e-commerce project. Let's perform some load testing using K6. We will increase the number of virtual users every minute by 20. When it's done, we see results, increasing response time. Now we want to deploy Kubernetes and scale the website inside it. So go to DigitalOcean and ask to deploy a new Kubernetes cluster. We are going to use same region, recommended settings, and the cheapest nodes with auto scaling. From 1 to 5, it will be just from 12 to 60 euros, depending on the load. It takes some time to deploy, and when it's done, you can download the config. When we get it, we go to our extension. Here we can connect to the Kubernetes using this config. Here it is. We see a list of deployed nodes with some information, and we can go to website and scale it step by step. We create backup. We build Docker image. Of course, these steps can be automated, but now it's more visible, and some steps require input from user. Now we push the image to a registry. It could be a local registry, it could be a registry inside Kubernetes, or any other registry hosted by DigitalOcean, for example. But in our demo, we use Docker Hub. Now we select cluster we want to deploy, and here should be settings for auto scaling and button to finally deploy container in Kubernetes, but we could not finish it in time, so we will use Helm to apply the changes. We create namespace in Kubernetes for our website. We add secrets for Docker registry and for HTTPS certificates. Now we deploy Helm chart with our container, and all resources are deployed in Kubernetes, and containers are available in Ingress. Now we can check site preview using IP of Ingress, and the website is online. We go back to the extension and we can switch DNS to the IP of Ingress. Let's repeat the load testing again. According to comparison, we improved the throughput in 3 times. Here is our repository and extension in the internal catalog. Here is our dream team of 3 Plesk developer and 1 Kubernetes guru. Thank you for your attention. Hope you enjoyed our project.